It's time to get busy and write our own codec and explain everything about codecs in detail. This will become a little bit of a long video, but stay tuned to the end because in this video we will talk about everything around codecs in Minecraft from the very basic to the advanced stuff. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In the previous video we had seen this class as an example. By default, nothing in Minecraft API should be marked as serializable. You just have the class and you define the codec. Minecraft will understand how to serialize it itself, so you don't need to mark anything serializable. Now, to add a codec, the very first thing you need to do is to define the public static final codec of type codec example and name it something. Because it's final, you have to either inline initialize it or you have to initialize it in the constructor. I personally prefer initializing things inside the constructor. However, for the codecs, maybe it's better to initialize them inside the static section and not the constructor itself, because this constructor is something that we will use later to deserialize things back. It may become a little bit of a wrong place to do it. Inside the static, we can say codec equals to, and as always, we said that record codec builder is our entry point and we want to create a codec. Okay, put the semicolon there. Now, remember, we have instance in memory and we want to use the instance.group. That's that. However, after the instance.group is where we want to apply the deserialization. So we say apply instance on something. Okay, this is the boilerplate of having anything related to codecs. Now we can start moving on line by line and then understand something. Let's start with deserialization because it's really easy. All we want is, for example, foo, bar, and block state goes into new codec example of that. However, you are noticing that it says create a constructor, and if we do that, it accepts object, object, object. Why is that the case? Because it still doesn't understand what are these. We said that it should be Boolean, a list of integer, block state. However, right now it says we don't understand these lambda parameters. If you want to make it work, create a constructor that is just accepting objects. And if I do that, you still see that the problem exists. It is not helping. It says that I don't understand anything. Now, to make things work, we have to tell the system what are these things and how can he handle these things. Now, let's start adding these elements one after another. Well, the first one is a Boolean. It's easy. And if you recall from our tutorial for the theoretic section, our entry here is codec. Now, if I middle mouse click on codec, you see that we have lots of things here and we have our primitive types at the end. However, we have tons of method calls on top. Unfortunately, none of these are documented right now. So if I say dot bool dot field of, there is no Java doc that I can use. However, we remember that this is the key name for the JSON. So it will be foo because I want to use the same name as the parameter and attribute. And then we have this for getter. Now, for getter is about how we can get the value from the object instance in memory. Here, as you see, the example that we provided inside the tutorial section, the theory section, says that we should cast to codec example something, example, and then we should use a lambda that says example.foo. Now, this works. However, if we say codec example, colon, foo, this will not work. Don't forget. So if you see this hint by Fitten, that will not work. All you have to do is use the codec example something and then use a lambda and say, hey, on this example, get the attribute. Okay, that's the very first one. Then we have the second one. The second one is a list of integers. So of course, codec.int. However, if you look, we have this list of. Now, list of is simple. It means that we have a list of integers that we can use. And again, we can use the suggestions because now we know that it's bar, it's the attribute from this example. And just right now, if you take a look at our deserialization section, you will see that foo and bar are solved. The only problem remaining is this block state. Now, block state, thankfully, is provided by Minecraft itself. And again, I really am happy that I have this fitten because it's really smart. It says block state codec field of this name, and the getter is block state, and that's okay. Here is the thing. The theory example that we had seen is using this lambda. However, you can replace the lambda with a supplier, and in my opinion, it's a much better approach because it's easier to read the code and understand it. This is the very basic way of adding your own codec to the system. Now, here is a question. Can we do it in a different way? Let's get this and let's comment it out. Let's paste it. We can say that when we are using the field of and for getter, let's remove this part. What if here I say codec example colon foo? Now, this should work in theory, but it's not working here. And I will tell you why in a few seconds. Let's take a look. If we take a look at foo, it says create method foo. If we have any encapsulation here, like get foo, come on, be smart. Get block state, for example, get bar, and let's add the foo, so it's public boolean. No, not this foo. Get foo that returns foo. And now I will make these things private. And instead of foo, if I say get foo and get bar and get block state, now it works. In other words, if you have private variables and you have encapsulation for those private variables, instead of using this lambda, you can go with this way of providing the attribute. Why is it important? Because if instead of this codec example, I have this public class, let's call it test, and let's make it an internal class so that we don't have any errors. And inside here, I have a record. So I have this public record, and I will call it testing. Now here I have int val1, int val2, and I will open the curly braces. Here I want to assign a codec to this record. So I will say public static final codec equals to create, thank you. After the create, we want to apply thank you, but not the instance.group. We want the instance like that, and testing.new. Now here is all the magic, isn't it? We call it like this. Instance goes into the instance.group, and this parenthesis needs to close at the end here. Okay, so finally here we will say codec.int.field of val1, and yeah, that's that. And this is our codec now. So this is the second way I showed you right now. That is being used on any record instead of using lambda. So if you have records and you want to create codecs for them, honestly, it's really easy. This is the way to add codecs for any record. Now remember, either you have to use your own primitive types or you use the types that is provided by Minecraft. For example, if I had a block state, the third one will be block state.codec fill of blah. Again, I'm using the codec that is provided by block state. If you take a look, the block state has a codec. It says that, hey, it's create codec. And we will take a look at this part later when we are working with block entities. Basically, the create codec is coming from the abstract class. And if we take a look, it's codec.dispatch, and then the name, a lambda, and how the codec works. So this is how Minecraft is defining the codec, but it may look confusing at the first because it's using xmap now, and we will talk about xmaps in a few minutes later, so stay tuned. We are just beginning. However, the bottom line is that if you open a class and you see this codec there, it means that you don't need to define anything yourself. Just call the codec, put the field and the getter, and get done with it. As simple as that. So I will comment this one because this is just related to an example of a record, and we will come back to the way we were working on things. So I will again comment this second one and move forward. Okay, now let's talk about a little bit of intermediate things. If I want to make something optional, for whatever reason, we need an optional, we can use a key here, and that is optional field of. Instead of field of, we can use optional. You get the problem, because if you want an optional, your return type should be optional. That's something that you need to remember. So for example, if my get block state would return an optional block state, then I could use optional field of on the block state. However, that's not the case here. Just remember that we have the optional field of as something that we can use for the key. And also one more thing. What if we want to assign a default value to something? For example, this default state. If we want want to assign a default block state when we don't have the value or we can't deserialize the value, we can use or else get. Asking for a consumer, we can say a consumer of type string and we call it system.out println, and then we have to use a block state. So blocks dot, for example, I don't know, acacia, let's say wood, why not? Okay, and then colon get default state. So what did I do? Let's break it down so that we understand it. Here, the thing that I did is that I'm trying to read this line and serialize it, and at the same time, I'm telling the system how to deserialize it. If at the deserialization we can't deserialize it, we say that if we get any exception deserializing the field, please first of all use the outprint in the log section of the IDE and print the exception message. At the same time, get this default state instead of the value that you couldn't parse. If you don't want to get something, but you want to handle the situation yourself, there is this or else that you can use. It just asks for a consumer on error and then block state. So if you use this, you can use or else this way. You could produce the consumer of a string to outprint the message. However, if you just want to default state and use it without handling the exception, it's another way using or else and just provide the default state for the whole thing. Now let's talk about a little bit of advanced stuff. When we are talking about this codec.int, the idea is that we are mapping an int string into int array and back. How about we do it manually? Let's comment this line and let's say that we want a codec.int string.xmap. Now xmap is being used to map things to each other. At the end, let's put a comma. And as you see, there are tons of overloads that we can use. However, here we say int string colon to array and then arrays to string. And that's it. Basically what we did is that instead of this codec.int.listOf, we had done it ourselves, and the rest of field.of and everything else should come after that. So instead of saying that, hey, blindly use the list of integer, we are saying that, hey, we have an int stream and we are using the int stream to array method, and then we will use array.stream. So basically you see that to and from, we are using a stream of arrays converted to int stream for the codec to work, and then this will not work anymore because now we need to have the variable itself like so. And you see that it's yelling at us because it's a list and not compatible with int array. If instead of using list, if we define it as int array, it will work like so. And you see that we don't have any errors on top. Before we go forward and talk about packet codecs, we need to talk about two advanced topics inside codec, and then we will talk about packet codecs. Up until now, what we talked about codecs were related to the situations that we have a direct way of assigning the codec and reading the codec. For example, they were primitive types, or there were the types that we had method calls, for example, for the list, or we had a predefined codec that we could use. However, there can be situations that we don't have a direct codec or a direct primitive type to work with. However, we have an easy access to convert the type that we are working with to a primitive type and back. For example, let's say that we want to work with identifiers. Now, identifiers are something that we don't have a direct codec for, and we can't directly use them as primitive types. However, we can easily convert an identifier to the string, and we can read the string and parse it to convert it back to an identifier. So for example, if we want to say public static final, and we call a codec on the type identifier, and we call it codec2. Now I will do the direct initialization here, and we say that it's codec.string, that's the primitive type. However, we don't have a direct way of calling identifier to string and string to identifier here. On the other hand, we have this xmap function. Xmap is being used to map something to something else. For example, here we provide a lambda and we say that s here is the string. So we want to convert an identifier to a string. And as you see, the parameter is set to. So here we say identifier dot of. Now here, the naming of the parameter is a little bit confusing because when we read to, we think that we want to convert the identifier to the string. However, it's the reverse. We have a string and we want to convert it to an identifier. So we are parsing parsing the string and converting back to identifier. The other one is from, and here we have an identifier, and we say that identifier dot to string. And this way, we can directly map an identifier to a string. And of course, I can call it a string here to make it more obvious. Of course, it says that now you can replace the lambda with the supplier, and that would work. Basically, we are reading a string, parsing it back to identifier, or we read an identifier and convert it to a string, and the X map is making a map connection between a string and an identifier. Okay, this was simple. However, at some times we are not sure if this parsing will work. In this example, it's straightforward and we know what we are doing. Sometimes this can cause problems. For example, if we are sending something like nbt string.of, and here we say a, B, C. Now, if I send it as a string and I want to parse it back to identifier, it will give me an exception, and this exception will cause the program to crash. If I want to handle the exception, I can use flat xmap. Now, flat xmap gives me access to the exception. So I can say try, and I open a case, and here I will say return data result dot success, and here I want to say identifier dot of s. Okay, and remember that here we are providing the s as a lambda, and of course I need to put these. Okay, what I'm doing here is that I'm saying that, okay, I want to parse that string. However, if it works, that's good, return the success result. If it has a problem and it is causing an exception, the exception will be invalid identifier exception, and we call it E. In this case, I want to make sure that I'm handling that exception. So I will say return data result dot error, and I will provide an anonymous class and go into the lambda because I want to send out a message. In this example, I'm directly using the text is invalid column, and I can use the e.getMessage as the parameter here. And finally, after the whole thing, after this lambda, I will say the other way around. So I will say identifier goes into data result dot success identifier dot to string. Now this part is okay because I can safely cast the identifier to a string and it will not cause any problem. The problematic part was the top one, and using flat xmap, we can handle that. Now, flat xmap, as you see, returns data result in both lambdas. The first lambda is the to, and the second lambda is the from. So in both of these cases, we are returning data result, either success or error. However, in this particular case, the second lambda has no problem. We always are able to convert identifier to string. So why should I have to handle data result in this case? In these situations, we can use something else called comap flat map. In comap flat map, in the second lambda, you don't return any data result, and basically it's just a normal identifier lambda that can be called using a supplier, for example, like that. And it's a simpler section for the second parameter. Basically, we have three different maps. Xmap is when we are sure that we don't get any problems, so we just want to map a type to another thing. The flat xmap is when we are not sure on both situations and we want to have access to those data results on both sections. The comap flat map is when we are not sure about the to, but from is clear and we know that here we won't have any problem, and we can use direct suppliers like this on the second parameter. So far so good. We had codecs to convert different situations and map them so that the serializer knows what to do. However, there are situations that the data itself, it's dynamic. Let's give it an example. Let's say that we have three different records. So we have a record called student. This record has a string name and int ID. By the way, I'm mimicking the example from Fabric Wiki now. And this is not a class, it's an interface. Okay? So this implements the codec example, and that's the first record. The second record is a teacher. Now, teacher will have a name. Also, it will have a string called subject and ID. The third record is a staff of the school, for example. This one has a string name, it has a string called department, and instead of int, now we have an identifier called ID. How can we define a codec that will support all these three dynamic records? Why do I say dynamic? Because each one of these have different parameters for themselves. So if I want to have a single codec that will handle them, we will have a problem. In these scenarios, what you should do is that you should provide codecs for each one of these records first. So in this case, we have a public static final, and instead of codec, now we use map codec because it's mapping this record to another thing. Basically, here we are saying that we want to map the student, and we call it codec equals to. Again, we have this record codec builder, but as you see, instead of the previous usage of create, we go with map codec, and instead of all of this, we have to do things differently. So let's open this up, and the very first thing we want is to add our lambda, and here we say i.group. So instead of instance, we go with I here. I is still the same thing, it's instance, and now we have to add each one of the things that we have. For example, string field of name for getter student name. Then we have int field ID, and yes, we have to apply and close the whole thing. Okay, so this part is just like any other codec. The difference is that instead of codec, we are using map codec, and instead of create, we are using map codec. And for each one of these, we have to repeat the whole process. So I will copy that. Instead of student, this time it's teacher. Codec equals to, let's see, yes, map codec, thank you. And then it says I group name, thank you, subject, ID, and apply. So as you see, Fiten helped me, but the whole thing is that we are doing the same thing. We are making maps for the base structures that we have, primitive types, string, integer, and everything else is the same thing. And finally, we have to implement the whole thing again for this staff. So equals I group name, department, and ID, and yes, apply. Now that we have codecs for each one of the records, we can move forward. If I want to have a codec for the interface itself, I have to cover something before I will be able to handle it. I have to assign a not null annotation, and I will call it a type and get type. Finally, we will say an enum that returns type, implements string identifiable from net Minecraft util. And basically, we are creating an enumeration. So it's a student, teacher, staff. However, for the student, we will provide a name, student. For the teacher, we say teacher. And for the staff, we say staff. Of course, now we have to provide a constructor that accepts a string name. Of course, then I have to add this name as a param. So I will say private final string name. And I want to have two string override that says return the name. I think I will use this implement methods as a string, not to a string. Okay, as a string, we return name, public string get type that doesn't accept any names. And we have to annotate this one as not null. Here we return type dot student. So that's the default one. For this one, again, for this enumeration, I have to assign another codec. So I will say after these, public static codec type, codec equals string identifier, create codec, type, colon, values, and we don't need the rest. Okay, so far so good. Get type is now here. Okay, my bad, it's inside the records now because you see that it says implement method get type. And here is type.teacher, and this one is type.staff. Okay. Now, what did happen so far is that we have three records that we added codecs for them, and at the same time, we made enumerations for their type. And if you notice, the type is codec example.type, so it's the type of this class. And this is why we are assigning types in the record now. So far, we did make maps for our records. We did make a map for our enumeration. Finally, at the end, we are ready to add a codec for the class itself. So we say codec of type codec example, and we call it codec equals to. Now here is the thing, type dot codec dot dispatch. Basically, we are making a dispatcher for the codec example colon get type, and then we want to change this second parameter to be a lambda. Type goes into, and we make a switch. We want to switch based on type, and we return. Here we say If we are case staff, we want the staff.codec. If we are student, we want the student.codec. And finally, if we are teacher, we want the teacher.codec. All we had done from adding the maps using the map codec and the codec for the type was to make us have the ability to use this part. What we had done at the end step is that we are telling the system that based on the type enumeration of this class, choose different codec to be used. And this is how you can make codecs when you have dynamic parameter count for different records inside a class and you want a final codec that will handle everything automatically. So if I have any other record, for example, outside of this class, I have a record and I will call it test, and this test has codec example and we call it example. And if I want to make a codec for this guy now, I can say public static final and not map codec, but codec. And you see that instead of map codec, we use the create. And like before, we say instance goes into instance.group. And all we had to do now, as you see, is this codec example dot codec. And this is reading this codec on top and filled out example for the getter. And at the end, like any other codec that we had, we can hit apply for instance test.new. And that's it, basically. And we are done with it. So I just have to add extra parentheses and the semicolon. Right now, I'm using a very complex class that has different records. And if I, for example, construct this as a teacher, I've used the type of teacher, and based on this switch, I will come back down and get the teacher codec. It will be wrapped with this codec, and all I'm doing is that I'm reading this top codec, and it will handle everything internally. And I don't need to be worried about anything else related to the dynamic situation sitting inside the example codec class. And that's all about codecs. It looks confusing at the start, but if you sit back and watch the video a few more times, then it will sit into your memory. Basically, what we have here is a very advanced example. Normally, in normal cases, in normal situations of modding, you are not face to face with this. However, there can be situations that you may have to handle things in this way. For example, I'm not sure if at some point Mojang drops the usage of NBT completely and you have something like an item frame, for example, and you want to handle different things. Each item type may have different records. You will come to a situation that you may need something like this. In those situations, this is how you should do it. Basically, you will have records, you will have map codecs for each record, you will have a type enumeration, and that type enumeration will have its own codec. And finally, at the top level, you will have another codec that is being used to read everything. That wraps everything about codec. Let's talk about packet codecs. Yes, we still have more things to cover. Now, let's say that I have something like this, public record, and no, I want to change the name this time. Let's call it student. Let's stick with what we have from the wiki example. And here we have a string name int id, but this time I want a vector 3D, three-dimensional vector, and I will call it pass. How can I make it so that I can send these information to our network? Of course, I can sit back and write a codec for this. If you want to send these information on a network, then you have to use different type of serialization. Now, we are not talking about networks in Minecraft yet, but because we are covering the codecs, we want to cover this part of the network handling. And that's basically serialization of objects on the network packets, on the data that you're sending back and forth between the client and the server on the network. And we call them packet codecs. So we will have a public static final packet codec, the single one, not the plural one. And this packet codec now asks for two things as a generic, packet byte buff, and the second type is the student itself. Now let's call it packet underline codec equals to packet codec not of, we use tuple. And for the tuple, here we have to identify different things. After the tuple, we have two things to cover. It's a student colon pose, comma, student colon new, and we will wrap everything. However, we have problems here because we didn't fix the tuple yet. Let's take a look at this. We say packet codecs, now the plural one, dot string this is equivalent of using codec.string. Basically, we are trying to make a primitive type into a packet codec, and that's a student colon name. That's the name. And then we have the ID. That's easier. Packet codecs dot integer, comma, student ID. Now the last one is a little bit more complex. Although Vector 3D has a codec, and of course we can use that. However, I want to make things a little bit more interesting and do a final step. I will call it packet codec, and this time I'm using this of. And as you see, if I put, let's remove everything here. After the of, I can use this comma and pose, comma, student colon new, and close everything. And you see that it's working. However, inside the of, now I want to map things manually. Here I will say that I have a lambda that is a value and a buffer. It goes into buffer dot write double. Now, if you are familiar with the old ways of writing a byte buffer, that's the same thing basically. We have to separate x, y, and z and write different buffers one after another. And then when we want to read them, we have to read them in the order that we were writing them. So the very first thing that we want to write is the x. After that, we want to write another double, and that is value dot y. Finally, we want to write another double, and that's value.z, and we put a comma. This is encoding. Encoding writes things into the buffer. On the other hand, we have decoding. On the decoding, as you see, the hint is completely correct. We have a buffer, and we want to make a vector 3D and return the vector 3D. Because we were writing 3 different doubles one after another, we have to read them in the same order. And as you see, it's the x, y, z, and we wrote x, y, z. Here, the order of operation is really important. For example, if I would write the z first and then the x, things would be very bad, because the first time I'm reading, I'm assigning to x, but the first thing that I read is this. Basically, if I want to put things here, it is like this. When I'm writing to the buffer, what I'm doing is I'm writing x, then I'm writing y, and finally I'm writing z. Now, when I'm reading from the buffer, I'm reading the first element, no matter what it is. And then I will assign that first element to x. I'm reading the second element, assigning it to y, and I'm reading the third element and assigning it to z. I don't know if the first element was really x or not. This is why the old way of handling byte buffers were really problematic, because people had to keep in mind what they were doing and how they were doing it to make things work properly. In other words, if I would write like so, what I'm reading here is the z value, not the x, and I'm assigning it to the x. And what I'm reading here was the real x value, and I'm assigning it to z. That is why when we were writing and reading from buffers in old days, we had to really be careful on what we were doing so that we would handle things properly. So as you see, this is the way, the new way to convert data so that you can read and write to the byte buffer and send that byte buffer on the network. When it comes to byte buffers, I should mention this, although it's not about network handling right now, but because we are talking about codecs, remember this packet byte buffer is extending byte buffer. So instead of packet byte buffer, we could use byte buffer and the whole thing would work because this is the base type. However, be careful. There are differences between the byte buffer, packet buffer, and registry byte buffer. These things are completely different because if you look, registry byte buffer extends the packet byte buffer, so it has extra functionality on top of the byte buffer. Packet byte buffer is extending byte buff, so it has extra functionality compared to byte buff. And byte buff is the base class that implements some interfaces. I suggest that you should sit back and read this whole Java doc from top to the bottom, at least to the top section of the class itself. Start from byte buff, then go to the Java docs of packet byte buff and then the registry so that you understand what are the differences and when you have to use what most of the times. For example, if you are working with enum sets, maps, integers, longs, enums, UUID, date, and many of the base structures, you have to use packet byte buff. If you look at registry byte buff, it says packet byte buffer bound to a particular dynamic registry manager. So if you are not working with dynamic registry, you don't need to use registry byte buff. Byte buff, on the other hand, at the very top, it says it's a random or sequential accessible sequence of 0 or more bytes. So this is the very base construct. I personally think that on most use cases, the packet byte buff would be more than enough. However, in some special cases, you may want to use that registry byte buff. And honestly, byte buff is something that I think has a very limited use cases now. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.